Yes, so I just rearranged, let me show you once again. I just rearranged my screen so that we can see presentation and my screen side by side. And I'm now switching to our weekly topics to the next presentation, stream states. And in those stream states, we have a few more things to say about states. So today we've seen a lot of formatted input output, and everything that we do like this and like this refers to formatted input output. And then we begin to analyze the possibilities of user errors as well as hardware problems. And the help that we get from the stream library comes through the maintenance of stream states. So every cout and syn object that represents stream states, also objects that represent open files, they come with the state. And there is a way to analyze the state and, if possible, to try to recover from input errors and continue with alternative paths, like we try to do over here today. Right. So if we have an endless loop like this, enter an integer, and we get integer from the user, and we accumulate it as a sum. If non-numeric input is given, like some sort of garbage, program misbehaves badly. Basically, this will run in very unpleasant ways, and it will just enter like truly endless loop with just trying to process the same garbage value over and over and over and over again. I would like to put together a bit of an explanation for what is the strategy with recovery from bad inputs. Let me just clear this whiteboard and try this one more time. So specifically right now we're talking about an input stream. Let's switch back to this color right here. So input stream, and internally, of course, it is represented by memory buffer, right? So there's some kind of memory buffer right here. And say that what we're trying to do with this input stream, as an example, it could be our standard character input stream as an example. What we do here, we say standard input give us an integer, right? Int val, something like that. Okay, so that's the attempt. And so if the user is typing over here 1, 2, 3, everything is okay, right? And what we're going to be able to do is just like take this 1, 2, 3 standard input will be able to preview this information, convert it properly to an integer, and populate our integer with this value. That's what's going to happen. However, if what happens is that a non-numeric input is attempted, so user types something like this, which is not good input for the integer, then what's going to happen is that first of all, so there will be an attempt to process it, but an important part of it is that input stream maintains sort of like a position of input, current position of input inside this memory buffer, like this, right? So it will attempt to process it from here forward. If somehow this attempt to do this input, process this input, and then populate our integer with this input, then what's going to happen is that the input goes into bad state, right? So the input goes into bad state. Okay, so this thing happens, but additionally, the position of the input will remain unchanged. so that if this input somehow was not processed for some reason, this ABC input was not possible to process, the input position would remain exactly the same, and in expectation that perhaps the program will try to do something alternative to this, something different, in order to process this input. So the input position remains the same. And that's the idea of the recovery. So if we're talking about recovery, so recovery means, first of all, somehow uh, get rid of bad input. Resize this. Get rid of bad input, right? And in our case, bad input would be considered this input. We just consider this is not appropriate input, and therefore we somehow need to get rid of it. Basically, what we need to do is that we need to move our cursor past it, like this, right? And move this cursor from this position to this position right here, and basically move forward. And this way we want to be able to essentially discard this input entirely and say, okay, this was all bad input. We want to refresh our memory buffer and retry. So recovery means somehow get rid of the bad input, number one. And this is exactly what I did over here, right? So when I said recover from bad input, I just decided, okay, I can create a string. I can say clear. Okay, so this is another part of what we need to do. So step number one would be right here. I can put here is that we need to do this clear, which means put stream back in good state. Okay, so step number two. And step number two is somehow get rid of the bad input. In my case, right here, attempting to get rid of bad input was basically declaring a garbage variable, and after restoring good state of the stream, going to get this garbage, populate the garbage variable with garbage, give the user some feedback if possible, and then continue, right? So this is what accomplished this second part right here, which was this part, basically somehow get rid of bad input, and then we can retry, give the user a chance to retry. So the next time we're expecting that maybe they will type once again. If they type a second time an acceptable input like this and hit enter, right? So they hit enter right here. Once the enter is hit, this is a signal to the operating system, at least with the console devices. This would be right here. This would be the signal to the operating system to say, okay, it's okay now to start processing this. And the character input would probably just take this part anyways, right? And be able to process it, essentially load this and populate our integer with this, and then the integer will be populated, and the input device will continue to be in good shape. And besides that, right, once this is all processed, all of this gets cleared, so it's already processed, and our cursor position that we try to or input position, will be somewhere in this memory buffer, ready to accept new inputs, right? So we can say that ready for new inputs. right here, ready for new inputs, and this here already processed. So everything that appears to be before, I don't fit very well into this buffer. I would have to start typing a bit earlier. So this is already processed, right? And so this is the functionality of the memory buffer. Basically, it knows what input has been already processed and what input is yet to be treated as new input. And basically, that's the functionality of this input stream when I think about it. It's basically, but remember, if we do get into a bad state, for some reason, because the input format was unacceptable or something, then the input remains in the buffer and it remains unprocessed and it's not lost, so that we can examine it, but it requires additional work. In my case, this is the way I tried. Okay, I just said that somehow I need to be able to get rid of the remaining input in case if there was some bad input, and then to continue. So this is the idea behind this example, where if we make no effort to analyze the state of the input and just create a loop expecting that everything will be well, it will misbehave very badly. It will just enter an endless loop because this garbage input would continue to be in the input buffer, and there will be endless attempts by SYN to, to continue input, but it will be in bad state, and that would create it would be just not possible to do it properly. So this is where we try to do it more correctly with some input examples. Okay, so this is the same example that we're using. Here we replace this endless loop, forever loop, with a different loop which checks the state of the character input device. And of course, because I'm here in the sample, it says it has this directive using namespace, standard namespace. We don't have to prefix like I do over here with the standard library namespace. But it doesn't hurt to use it in front of SYN and cout. When you use it, it's the same thing. Is just that you can. I'm not in big favor of those directives, so I prefer to use full names of objects like this without using declarations like this. But anyway, so in this example, we're starting to check on the state of the input to be able to do some work with recovery. However, this is not a bulletproof version of recovery, because we still leave SYN in failed state, which we are going to discuss next.